All right, folks, here we are. This is 17.2, day number 1. I want to plot a couple of points here. What we're going to be doing today is converting rectangular complex form, such as this. Here's rectangular complex form. Let's say 1 plus I. And we're going to convert that to polar complex form. This may or may not make sense right away, depending on your background. But that's going to be root 2 cis pi over 4. For those of you who want a visual of that, in the first quadrant, if this is the real portion of our number, what we call z, this is our imaginary portion of our number z, then if I go to the right one and up one, what I'd find is the hypotenuse is root 2 and this angle is pi over 4. So here is my hypotenuse, here is my angle, and I'm going to make sense of this cis thing in a few slides here. So let's go ahead and plot these 4 points. As you'll notice here for the purple point z, this is my real portion, imaginary portion. So here's the real portion of z, here is the imaginary portion of z. We're going to go right 5, 1, 2, 3, 4, 5, and down 1. There is the point 5 minus I. Okay. The green one here, this might look confusing, but if I write it out in this form, we have no real portion. So we're not going right or left. We're just going to travel, as you can see here, up E units. And E is between 2 and 3. It's like 2.71. So that would be the point. We could write it as 0 plus EI, or just EI. Okay, the blue point is going to be in the third quadrant. We're going to go to the left. I think it was negative pi minus I root 7. Okay, we would go to the left 1, 2, 3 in a little bit, right, to pi, and down. Root 7 is between 2 and 3, right, because root 7 is between root 9 and root 4. So it's somewhere between 2 and 3. Okay. So if I go left pi and down root 7, I'd end up right about here. Okay, these are all in rectangular form, obviously. And I think the fourth one was z equals negative 9. Now that is missing an imaginary portion. So we're going to go out 9 units, 5, 6, 7, 8, 9, and we're not going to move from there. That would be z equals negative 9 plus 0i. A little bit of plotting, let's move on. Okay, here we are. This is the big deal for today. Complex to rectangular polar form. Okay, so we're used to seeing this, right, where x and y gave us some value r. Here's theta. Today we're going to use a lot of the same ideas in a different form. We said here that x equaled r cosine theta, and we said y equaled r sine theta. So today in our diagram, x is going to be replaced by a, and y is going to be replaced by b. So what I would get is r cosine theta for a, and I get r sine theta for b. Okay, r is going to be calculated using the Pythagorean Theorem, using a and b now instead of x and y, and theta will be the inverse tangent of b over a instead of y over x. Now, why do we do this? The reason we do it is so that we can take a plus bi and put it into this polar form. So a, we said, was r cosine theta, and b was r sine theta, but we can't forget this I here. Now what's cool is in the next step, both of these have an R, so we factor it out. And I'm going to bring the I in front of the sign. And what we're able to do then is kind of like modern day language in shortening to an acronym, is we call this form cis form. Where does the cis come from? Cosine, I sine. That's where cis comes from. So this is just a shortened version. We're going to skip from a plus bi form directly to this form r cis theta. All of this information right here is basically what we just talked about on the previous page. Okay, let's implement that into a couple of problems. Before we do that, what I'd like to do is each of these problems are, I'm going to put them into, draw them into a triangle and then identify these items, the real portion of the imaginary or complex number, the imaginary portion of the complex number, what's called the modulus. This is the modulus, right? Modulus is this absolute value of z, right? And then the argument. The argument of z is our theta. The modulus is our r. It is our hypotenuse, okay? So if I were to sketch number 1, I'd go right root 3 and down 1. Right, so that creates a triangle. Okay, the hypotenuse of that, if I'm uncertain, what I would do is I'd sketch one that I know. Right? I know a root 3 over 2 and a negative 1/2. That makes the hypotenuse here 1. Well, what I could do is double each of these numbers to get the numbers I have, and therefore that would have to be 2. So as I look at these items over here, identifying these, the real portion of z here is root 3. The imaginary portion of z is negative I. The modulus is the same as r, which is 2. And the argument, you just have to be able to identify here, is negative pi over 6. Okay, so let's look at a different example. Let's look at another one here. Let's go ahead and look at 3. All right, I'm going to rewrite this as 0 plus 3i. All right, so if I were to sketch that, I'm going 0 units right or left, but I'm going up 1, 2, and 3. That's the point. That's the point. Oh, I just totally got rid of that. That is the point z equals 3i. Now this is kind of funky, but there's no triangle. Well, when I talk about these then, and I talk about the real portion of z, well, that's just going to be this 0. Right? There is no real portion. The imaginary portion of z is going to be 3i. The modulus of z, which is the same as the radius, is just going to be the distance, the absolute value of the distance. So that'll be 3. And the argument of z is going to be this angle of rotation, which is pi over 2. All right, so let's apply what we know now to a couple of problems here. I think I'm going to do A. This is in honor of Harry, Keppen, Jake, Karen, and Frank Isaacson. I'm going to move this out for a moment here. Okay, and I want to do A, and how about C? A and C. Okay, I want to take this polar. I want to find the rectangular form of this polar coordinate, right? All that this means, right, that's r, which is the same as the modulus, which just means extend. Let's extend 4, and then let's rotate, right? This is theta, which we call the argument, which is rotate. So let's extend 4 and rotate 2 pi over 3. If you're with me here, if I extend 4 to the right and then rotate 2 pi over 3, I'm going to end up right about there. All right, so that tells me that the modulus, or the hypotenuse of that triangle, is 4. If you're struggling, right, you can find that angle, which we know, right? If this angle here is 2 pi over 3, that makes this angle in here pi over 3. Okay, if you just know it right off the bat, you can say that's negative 2, and that is, what would that be? 2 root 3. If you're uncertain on how to get those side lengths, then what I would do is I would compare it to a triangle that we do know. So I know the unit circle relatively well. I know if that's 1 and this is pi over 3, then this has to be root 3 over 2, and this has to be negative 1/2. So in order to get 4 from 1, I have to multiply everything by 4. And if I do that, I get negative 2, and I get 2 root 3. So this polar coordinate, z equals 4 cis 2 pi over 3, is equivalent to, it's equivalent to this rectangular coordinate, negative 2 plus 2I root 3. Notice I toss the I back in there after I've come up with that rectangular coordinate. All right, one more. Let's try, I don't know. Let's do part D. Okay, here's my polar coordinate, or my polar point. I'm going to put that in rectangular form. First thing I'm going to do is I'm going to graph it. So I extend out 1 unit to there, and I rotate pi over 2. Puts me at that point right there. Okay, now, again, we just want to identify that point. The length from here to here, that's going to be our modulus, right, which is the same as r. Okay, what would that be? Well, that would be 1. Is there a real portion involved here? No, I'm not traveling to the right or the left. So this point right here would be z equals 0 for the real portion and 1I for the imaginary portion. All right, I think I want to do one problem from the homework. Let's just check it out. I don't want to go from one form to the other. Thank you, Cindy. Let's see. Find a polar representation for that. I want to do, yeah, let's do one of these. Okay, 7 root 2, I like 23. Let's put that into rectangular form. So I'm going to extend 7 root 2. I'm going to rotate pi over 4. That means I'm going to get a triangle that looks like this. Okay, now we're used to, maybe you're not 100% sure what to do here on how to find this point in terms of A and B, but you can always go back to the unit circle. If that's 1 and this is root 2 over 2, then this would also be root 2 over 2. That is if that's pi over 4. Okay? So what do I have to do? I have to multiply this by 7 root 2 to get this over here. So if I multiply this by 7 root 2, what's going to happen? Ooh, this is interesting. I like this. Well, this is going to become 7 root 4 over 2, which is 7 times 2 over 2, which is 7. You might have already seen it, and you knew right away. But this point z, right here, in rectangular form would be 7 plus 7i. All right, folks, I hope that helps. We can do some more in class if you want it. Like, subscribe, comment below. Have a great day.